Expand 1 plus p raised to the power 4, hence evaluate 1.99 raised to the power 4. So the first thing to do is just obtain this binomial expansion. So we're going to need, number one, the coefficients for the expansion, and then we're going to look at how the powers of a and the powers of b change across the expansion. So the first thing is to obtain the coefficients of that particular expansion. So how do you do that? We use the Pascal's triangle. So from the Pascal's triangle, we need the row number 5, that is n plus 1, and n is 4, so 4 plus 1, that is 5. So we generate the Pascal's triangle up to the 5th row. So the first one, when n is 0, we have the coefficient of 1. When n is 1, we have 1, 1. Then so 1 plus 1, that is 2. Then 1, 1. 1 plus 2, that is 3. 2 plus 1, that is 3. Then 1, 1. Then 1 plus 3, that is 4. That is 6. That is 4. So we have 1, 2, 3, 4, 5. So this is the row that we require. So we're just going to list them. We see that the coefficients are 1, 4, 6, 4, 1. Then you observe the powers of 1, that is 1 power 4, 1 power 3, 1 power 2, 1 power 1, and 1 power 0. Then you also observe the powers of p. So in this case, p will increase from 0. So we have p power 0, p power 1, p power 2, p power 3, and p power 4. So all we need to do is just multiply them down. So we have 1 times 1 times 1, which is just 1, plus 4 times 1 times p, that is 4p, plus 6 times 1 times p squared, that is 6p squared, plus 4 times 1 times p cubed, that is 4p cubed. And finally we have 1 times p power 4. So that is the expansion. But we are required to evaluate 1.99 raised to the power 4. So what we're going to do, we're going to rewrite 1.99 power 4 as a binomial, meaning you're going to represent this value by 2 terms. So we can even say that this is the same as 1 plus 0.99. So if that is the case, we just compare this binomial with the binomial that we have expanded. So we say that is the same as 1 plus p all raised to the power 4. So if that is the case, the powers are the same, and the first term corresponds with the first term, the second term with the second term. So it means 1 is equal to 1, obviously, and it therefore means that 0.99 is the same as p. So from there we get that p is equal to 0.99 according to this expansion. So for us to obtain this value, we just use our expansion. So wherever there's a p, we replace that with 0.99. So let us do that. So we're going to have that 1.99 raised to the power 4 is the same as, we have 1 plus 4p, that is 4 into 0.99, plus 6p squared, that is 0.99 raised to the power 2, plus 4 raised to the power 3, that is 0.99 raised to the power 3, plus p raised to the power 4, that is just 0.99 raised to the power 4. So we can simplify this. You have 1 plus 4 times 0.99 is the same as 3.96, and you have 6 times 0.99 squared, that is the same as 5.8806. 5.8806 plus the next one that we have is 4 times 0.99 cubed, that is 3.881196. Then finally we have 0.99 raised to the power 4, that will be 0.960596010. So if you work this out, you're going to get this to be 15.68239201 as the expansion or the solution for 1.99 raised to the power 4. So to check if you're right, you can just key in 1.99 raised to the power 4 into your calculator. Thank you for watching. Kindly do not forget to subscribe.